Okay, in today's lesson, we're going to look at transformation. So, just of recent, we've been looking at scatter plots, and so here was one we did like the other day, birth rate against life expectancy. So we created up a scatter plot and we put the least squares regression line onto it. Now, when we do the least squares regression line, we're assuming that it's linear, and remember we did down here, we do a residual plot to test our assumption. And when the residual plot has no pattern like this, we're going to say that it is linear. Okay, so now with data transformations, what we're going to look at is when the residual plot does have a pattern. So if you look down here, we've got another one. So we've just done X and Y along here. So this would be our explanatory variable, response variable. So we've created this scatter plot and done the least squares regression line. And so when we did that, we assumed that it was linear. And so we did a residual plot down here. So here's the residual plot that's been created. Now with this residual plot, we're seeing, you see a pattern. There's like a, can you see, it's sort of like a curve in there. So it's not random, it's got a pattern. So when it has a pattern, we're going to say that it's non-linear. So when it's non-linear, it means we want to do some changing to the data to try and straighten it up to make it a linear relationship, and that's called transformation. And so what we're going to do is we're going to change one of the lists. So we'll either change the x value or we'll change the r values, and we can change it by doing certain things. We could square them. So we could do an x squared list versus y, or we could do a y squared list versus x. So that's called a square transformation. Another change we could do is where we log all the values, and another one is the reciprocal. Now just take note, the reciprocal is when you say 1 over, so 1 over x or 1 over y. So how do you determine what transformation you should do is we're going to use this circular table here, and this helps us pick which transformation we can do. So if I look down over here at this scenario, this is because we're going to look at this one because we know it's not linear. So because it's non-linear, we're going to do a transformation. So when you are trying to decide, you go back and look at the original scatter plot. So when I look at the original scatter plot, can you see it sort of has a curve in there like that? So you try to find what part of this circle over here it looks like, and I think it looks up like this. So what would be the best transformations for this data would be to either log the y values, that's one thing you could do, or you could do a 1 over y, or you could do a x squared transformation. So we're going to have a look at some examples and work you through it and show you, because we've got 3 options there, and I'm going to show you how you can decide which one's the best option. So here's an example here. We've got the table below gives us the human index and the mean number of children per woman in 14 countries. So they've pretty much told me, because I can see the graph, so I know that that's EV and that's RV. So I just pop that maybe on top of the list so I know. And what we're going to have a look, so we look at this data. So if you have a look, I've popped it into the calculator, the 2 lists, and I've created a scatter plot over here. Now, when we've done the least squares regression line, and what we see is that we are seeing a pattern in here. So because there's a pattern, that indicates nonlinear, and we will need to do a transformation. So, all right, we need to do a transformation because there's a pattern there. So we need to look at our part of our original scatter plot, so I'm going to use this one. So I can see here that it's that curve. Now if I think about back at that the circle, so I think back at the circle, this graph probably looks more like this side of the circle. So these are the possible transformations that you could use. Now in exam questions they often tell you which one, and they've told me a log has been applied to children. So that's like saying, because the log is the RV or the Y value, they've done a log Y, which you can see is one of the options there. So I'm gonna show you, when we showed you on the calculator, we're gonna look at changing and now which one's the best. Okay, so we go back to our original list. So in the list I'd put the two lists. So here you can see it was the explanatory variable and the response variable. Now because we're going to try a log Y transformation, which would be the children list. So what you do is you label your list, give it a name. So I'm going to call it log children, so I know. And then underneath in this formula bar, you'll see down here, this formula bar, you're going to press equals. And once you call equals, you'll see this dark, the name come up and equal. And then you type in what you want to do. So you want to put in log 10, which you find on your calculator, and it opens up the bracket. Now, when you type the word children, you'll see it goes dark because it's picking up that you want to use that list, and you press enter and you'll see all your children values have been logged. Sometimes it says log 7.6, that's okay, it's your calculator's in exact mode, that's fine. Alright, so you have all your logged values now. So we've tried this, we've logged the values, and we're going to go try making a scatter plot with that. So you can see over here, we now don't have Y, we have log Y and still our X here, which was HDI. So I create the scatter plot, I put the least squares regression line on it, and then I check the residual plot. You can now see that the residual plot is random, so no pattern. So we're going to say yes to linear now. Okay, so once you have it at linear, you want to write the new equation. So we want to write this equation out here. Now you can see it here, or you can get it back on our list. So remember, we can, to get these values here, we press menu, stats, stat calc, and then you're looking for the lin reg a plus bx. So you get this little screen over here. Now you're going to remember you didn't change your X list, you still use HDI, but you changed the Y list, so make sure you pick your new list and then you press enter, and what you would get is these values here. Sorry. Now your A values, so you could write out your formula now. So when I write my new formula, I have to actually write log children, because it's not Y anymore, or Y equals, it's log equals. Log children equals, and I would write 1.05 minus 0.0095 times HDI. So there I've written the equation out, the new this is the transformed equation. Okay, now another thing we look at, when we had, if you saw, we had a couple of transformations we could have done. Now we need to, when we do a few and we want to know which one's the best, what we will be looking at is the R squared value, and this one's R squared value had a was 90, so R squared was 0.91. So if you want to go compare, you compare all the transformed R squared values, and whichever's higher is better. Okay, here we have another example of transformation. So the table below, they've given us x and y and shown us on the scatter plot. They mention here that the scatter plot is non-linear. So if it's non-linear, a transformation is going to have to happen. So transformation needed. So as I said, in exams, they generally tell you which one they're going to do, and they've said here a squared is applied to the x variable. So you've got your lists here, and you need to create an x squared list. So if you look over here on my calculator, I called it SX as in squared x, and then in the formula bar I told it to square the x values, and it's done that and created a list. Now they want me, the actual question is to find the least squares regression line. So once I've done that, I'm going to go in and do the menu, stats, stat calc, and get the lin reg a plus bx, because I'm going to try and find the a value. Now what I've got to be careful is when I press the x list that I use the transformed one, which is sx, and the y list hasn't changed, so I leave it as y. So when you do that, out comes your a and b value. So if I have a look over at the answers over here, we have, now remember when you write out the equation, it'll now be y equals negative 1.34 plus 0.55 times x squared. So remember, you've got to change, it's not just x. So over here I could cross that guy out because it's not an x squared, same with that one. So then I look at my answers, clear, and it's there. So if you have a look at the r squared value for this one, it's got a 98. So I'm going to talk about if we're asked to compare a few transformations. They told me which one to do here, but what happened if they didn't? So as we can see, this is that data from the page before. So we've got x and y, and it produced that scatter plot. And when I looked at this residual plot here, the residual plot has a plot, shows a pattern. So therefore that means non-linear, and we have to do a transformation. So if I have to do a transformation, I'm going to look at the original scatter plot. Now it looks like it's this part of my transformation circle. So I could do a log y, a reciprocal of y, that's called reciprocal, remember? Of y, or I could do an x squared. Now we just did the x squared one here, and here I said, and we found out that's the r squared value. So what I'm going to do is I'm going to try the other ones as well. So I'm going to do a log y. So I created a list. I created a list here where I logged all the y values, and then I went and did the linear reg, and I found out that its r squared value is 0.93. Then I tried again, and I used, I tried the reciprocal of y, so I called it ry, and here's where I popped it in the formula, and I created that list. Then I went and did the lin reg, and I used the change lists, and I got an r squared value of 0.55. So you can see that this one has the highest, would be as a percentage, it would be the highest. It would be 98%. This one would be 93%, and this one would be 56%. So this one is the best transformation because it has the highest the highest r squared value. So what I'm saying is the highest r squared value is better because we're saying 98% of the change in the y value is due to us changing our squared x values. So that means it's having a major impact on it. So it's very much related. And then once we've done that, we have now made this data linear. It's no longer curved. So we can be happy that we can use our equation to predict. So let's just have a look here. So here I showed, just sort of summarized it out. So when I did the x squared transformation, this was what the a value and the b value was, and this is my formula. Now when they ask you to predict, you're going to use this formula. And so I've shown you an example. So they say predict y when x is equals 2. So all I did is, because that formula is a y equals, I popped that into the calculator, and where I saw x, I put 2. Now remember it's x squared, so I squared it, and there's my prediction. Y would equal 0.8. Now with this next one, when we did a log transformation, the formula changes to log 10y. So when they ask me to predict y when x equals 2, you got to remember this formula is log 10y. It's not a y equals. So the best way to solve for these is to use the solve function, and you just type the whole equation in, and instead of x we'll put 2 and we'll go comma y, and then it gives us the answer as y equals. So not a log 10 answer, it gives me a y answer, which is what I need. And the last one that we've got there, we did a reciprocal of y. So remember that's reciprocal. That's a way to say it. So it's again written as 1 over y. It's not a formula for y equals. So you can see when I substitute in, I'm going to put the 2 where the x is, but it's 1 over y, but I write comma y and I get my answer in. So that's a prediction. You just got to be really careful with that. So I suggest you just use the solve function and you will be fine.